But the equations that you use for both of these are exactly the same. Okay, so let's look at growth versus decay. In both cases, we use the exact same equation. So if we look at the equation, y is equal to ab to the power of x. Okay, this is true for both growth and decay. And that's the equation that you're using. The only difference is, in this case, in growth, the absolute value of b is greater than 1. In decay, the absolute value of b is less than 1. And there's a couple different ways that you can approach this relationship or derive this relationship. Okay? The easiest or the first way is to just have a base that fits that number. So if you're looking at an equation like this, y is equal to, and the a value can be anything, whether it's positive or negative. So I'll use a positive to start with. Okay, so this would be a growth model. Okay, the base of your power is a number whose absolute value is greater than 1. Okay, now, what if I had that same thing, but this base was a fraction? So I'll even make it 2/3. If my base is 2/3, now that absolute value of that number is less than 1. So that makes it a decay function. All right. Now, there's another way that you can reach both growth and decay, and that's using negative powers. Okay? Because if I did this, what if I took this equation, y is equal to 2 times 2/3 to the negative x? Okay, what does that negative power actually do? What property does it apply to your base? Matthew? Well, just to the base that it applies. This negative power does what to the base? So it, yeah, flips it. It's a reciprocal, right? Remember that property of negative powers? So really this quantity is exactly the same as 2 times the quantity 3/2 to the positive x. So what you could do in that particular case is that would allow you to identify that you have a growth model. And so when you're given an expression, what I would recommend that you do is rewrite it without the negative power. Okay, so let's say we took the following. Okay, so here we have 3 times the base 2 to the minus x. What I would suggest that you do is, before you try to identify whether this is a growth or decay model, I would rewrite it using a positive power. So this negative power will flip our base. It inverts that base. So instead of a 2/1, it becomes a 1/2. And now the rules, the absolute value of this base is less than 1. So this is an example of decay. All right. Does that make sense, how that can work there? When we talk about the graphing things, I'll show you how the negative in the power will cause a reflection of the graph. But for here, probably the easiest thing is to just rewrite it with a positive power and flip your base, if that's the case. All right, so let's try, see if you can figure these out. So try to figure out, is each of these growth or decay? Growth or decay? This base is smaller than 1, so it is decay. Okay. Okay, what about the second example? You think that's a growth or decay? Growth? Anybody agree with Jack? All right, so this negative power does what to your base? it flips it, so it becomes 4 over 3 to the positive x, and now you can see the rules. It fits. Oops, this is a matter of growth. Okay. Let's try the following. Growth or decay? So is the base of our power a number less than 1 or greater than 1? Less, so it is decay. And so what about this last example? Is that growth or decay? Okay, our power is negative, so let's flip it. It switches our base from a 5/2 to 2/5. And so now you have the rule, which makes this decay. Very good.